Welcome to Someone Like You, the podcast where we challenge the old rules of business to build something better. I'm your host, Marco Pimentel, marketing expert, entrepreneur, and lover of bold, sustainable ideas. Today, we're tackling one of the biggest threats to global agriculture: unpredictable climate weather patterns. Farmers are facing devastating losses. Just this past year, 80 to 95% of wine grapes in British Columbia, Canada were wiped out due to extreme frost. Cherries, peaches, and other fruits across North America suffered similar fates. With climate change creating wilder temperature swings, traditional crops are struggling to survive, and the economic losses are staggering. That's where today's guests come in. Sue and Jerome are leading a breakthrough in plant science that could change the future of farming. By enhancing nature's own defenses, their innovation helps crops withstand extreme weather, potentially preventing billions in losses for farmers worldwide.
I worked at the National Research Council, and when I started there in the 70s, I thought, how could an organic chemist help with plant agriculture? And so I looked into chemicals that related to plants' ability to withstand stress. And there's one that's really well known, and it's called abscisic acid. And what I did with a really good group of people was to say, we know what the chemical structure of this natural product is that helps plants cope with environmental stress. Can we change the molecules subtly, change a carbon here and a carbon there, and make a molecule that lasts longer and could be used in practical applications?
For farmers, this could mean more than just survival. It could mean stability, resilience, and a future where unpredictable weather doesn't determine their fate. And the scale of the problem is enormous.
In Canada alone, there's over 30,000 acres of wine grapes grown, and tree fruits in general are approaching 500,000 acres. It's safe to say that the issue is pretty widespread in Canada, and we've had a lot of damage over the last 15 to 20 years, and the frequency of these extreme weather conditions has gotten very high. And so what we're finding is that out of the last 6 years where we've tested our product, there's 5 years where our product made a difference.
Of course, bringing an agricultural breakthrough to market is a battle of its own. Between regulatory hurdles, manufacturing at scale, and making the solution affordable for farmers, the road ahead is complex.
We're having people who have expertise in the field do the testing at Penn State and Cornell, and once we get registration in Canada, then Canadian researchers will be able to use it in the field as well.
So how do you take a scientific breakthrough and scale it into a real-world solution? And what does this mean for a future of food security? Let's dive in. Sue and Jerome from Abazine Bioscience, welcome to Someone Like You.
Great to be here.
So today we're talking agriculture, and obviously climate change, weather patterns, changes in, consumers' options have kind of made life pretty hectic and difficult, being a farmer or owning an orchard or growing grapes and wine. And so before we get into talking about what you've built as kind of what you think from a market perspective and grow into, I'd just love to understand, how did you find this market and how did you come across this idea that we can use kind of nature to help nature?
I'm going to let Sue answer that. She was the initiator, inventor of the technology.
Well, that's a very good way of putting it. I worked at the National Research Council, which has had a lab in Saskatoon that worked on plants. And when I started there in the 70s, I thought, I'm a chemist, an organic chemist. How could an organic chemist help with plant agriculture? And so I looked into chemicals that related to plants' ability to withstand stress.
When a plant is under stress, whether from drought, extreme cold, or heat, it releases natural hormones to protect itself. One of the most important of these is abscisic acid, or ABA. The problem is ABA breaks down quickly, limiting its effectiveness. What if we could just extend this lifespan and make it more efficiently? That's exactly what Sue set out to do.
And there's one that's really well known, and it's called abscisic acid. And that's what we named our company after. ABA is the acronym for abscisic acid, and our company is Abazyne, ABAZYNE. And what we did, essentially, what I did with a really good group of people, was to say, we know what the chemical structure of this natural product is that helps plants cope with environmental stress. Can we change the molecule subtly, change a carbon here and a carbon there, and make a molecule that lasts longer and could be used in practical application? So that was generally the idea, essentially to do pharmaceutical research on plant chemistry. And it was possible to do it. This molecule only has 15 carbon atoms. It's a small molecule. It's sort of a chopped up carotenoids, or the colored substances in fruits and vegetables. So it's a chopped off little guy like that. And we just made modifications to it until we found ones working with biologists. All of this involves working with people who could test all the molecules we made, just like pharmaceutical research. And eventually we found a couple that worked really well to give a long, persistent effect, similar to the hormones, but the hormone is turned over naturally in plants to get rid of it when the stress or whatever is not there anymore. So we built a longer lasting one, and then it took years and years to do this. And when I moved to the University of Saskatchewan after the NRC changed its mandate, I had a really good researcher join the group who figured out how to make this molecule that was long-lasting, but how to make it in 2 steps from the natural plant hormone and make it efficiently. Meanwhile, we've been working with biologists all across the country and around the world, and one set of people were in British Columbia at Summerland working on grapes, and we found that our molecules would work well on not so much cold hardiness, but drought tolerance and that kind of thing. And we kept going and worked eventually with one of the people who moved to Brock University in Ontario. And he is interested in cold hardiness because that's a problem in the Niagara region as well. And found that our molecule sprayed on the leaves of grapevines after the fruit had been harvested, spray the leaves, the chemical gets into the plant, gets transported to all over the plant, and then the leaves fall off in the fall after in the normal way, or actually even helped a little bit by the chemical. And the plants are able to survive significantly lower temperatures in midwinter, 6 degrees or so more cold hardy. And the other benefit is that the spring frost problems are avoided by having the grapevines stay dormant for longer. So you get 2 benefits. One is midwinter cold, and the other is avoiding spring frost. So this chemical essentially helps plants deal with unusual weather patterns that are colder than normal.
Yeah, and I guess I'm a bit of a special position because I live in BC and I get to understand a little bit of this space. And you hear this in the news all the time, where this year, specifically in the Okanagan, which is kind of like the Napa Valley for Canada on the west coast here, is that there were reports of 90 to 95% loss in grapes. Most cherries were pretty much down to 10 to 20% of normal production. We lost all of our peaches. And this is not just in BC. There's issues with the peaches in Georgia and North America. And so I'm sure there's issues all over, and we're seeing this all over the world, is that what we plant and now these new temperatures that we're realizing is just different. And I don't know if it's because maybe this is not native plants that were planted here. We're using this for food. They can't deal with these colds. So I guess the question is, how big of a problem is this from an agriculture perspective? And what are we seeing as right now? And is there any solutions to address this?
So for solutions to now, there aren't really good solutions. In France, you'll see smudge pots in valleys trying to raise the temperature that way. But Jerome has looked into, and his crew have looked into, the market potential.
Yeah, so the market potential is fairly significant. In Canada alone, there's over 30,000 acres of grapes, wine grapes grown, and tree fruits in general are approaching 500,000 acres. And it's safe to say that the issue is pretty widespread in Canada, and we've had a lot of damage over the last 15 to 20 years. The frequency of these extreme weather conditions has gotten very high.
We're not just talking about small fluctuations in crop yields. Farmers are experiencing total crop failure. 90 to 95% of wine grapes in British Columbia, Canada were lost last year due to extreme frost. Peach and cherry growers across North America are reporting similar devastation. Climate change isn't a future problem, it's already reshaping agriculture, and for many, the options for adaptation are limited.
And so what we're finding is that out of the last 6 years where we've tested our product, there's 5 years where our product made a difference. Now, in the rest of the world, for example, I have a chart in front of me where we're looking at France and the market opportunities in France. And we're just looking at the number of acres that have been affected by frost damage in France alone, and that is 1.1 million. California has had issues with frost damage, but we also see in northern states in the United States problems similar to Canada, and we've tested our products in New York State and Pennsylvania, and it has the same effect it does in Canada. So there, in total United States, we'd have over 1 million acres of grapes. California alone has 1 million acres, and the rest of the country has just under that amount. So it's a worldwide issue. And Spain is another area that we're doing the market assessment, and we're finding again about 1 million acres that have been affected by this. And that's just grapes. So our product has potential applications in a wide variety of tree fruits, and we're just expanding our research to validate and to determine how effective they can be and in which varieties. The product works differently in some varieties because, as you said, some of them have a more natural resistance to cold weather than others. And so our research and our marketing strategy is to target those areas that are the hardest hit and with varieties that are damaged the most because of this. But it's pretty extensive. As you gave the example in BC, 90 to 95% of the wine grapes were damaged.
Grapes are just one example of a crop struggling with climate extremes. But this same issue, crops failing due to drought, frost, or heat stress, affects nearly every type of fruit tree, vineyard, and even row crops like soybeans and canola. If this technology works, it could be a fundamental shift in how farmers protect their crops in a warming world. Is the issue the varieties that we planted? Like, for example, talking west coast of Canada, people love red wine. So we planted maybe varieties that just couldn't deal with these cold temperatures. And now because of climate change and these differences, we're seeing, wild variations of weather. So is that part of it? Is it just the wrong varieties in the wrong areas? Or is it just a kind of a combination of all of it?
Well, I think it's a combination of all of it. The first external factor that's a difference is the weather patterns are changing, and we're seeing more variation in weather, cold spells, warm spells. That's the big issue. But some varieties are hybrids, and they are being bred to be more resistant to frost. But there's a limit as to how far you can take that. There's a limit as to how far genetics are going to work. And so some varieties are naturally, it turns out that the older, more traditional grape varieties that are more susceptible are the ones that are more valuable and the ones that are the popular wine variety. So, of course, those are the ones that we're going to target because they come from that history. Plant breeders are working on trying to improve that, but developing a particular trait through a breeding program can take decades.
Yeah, that's what I was reading about as well, is yes, you can breed and you can replant. And Sue and I, before the conversation started, we're talking about where this year is like, if you were a grape grower and you had insurance to be able to replace your vines, what do you replace it with? Because you have to wait the 4 or 5 years before you can even get some fruit. But that's really risky because, it's going to take 4 to 5 years. You got to tend to it. And then, is that the right decision? Because 4 or 5 years, it might be the same thing and repeated again. So it ends up being very risky.
It's not only risky, it's not affordable. People can't afford to cut their production in half or even more and still be able to keep a viable operation going.
And maybe correct me if I'm wrong. I may be dumb downing the science here, of course, but my understanding really is that nature has its own essentially antifreeze, and you're being able to allow that antifreeze to come a little bit sooner and a little bit longer later in the season. But you're a startup, and if I think about agriculture, it is dominated by big, large corporations with deep pockets. So are the large corporations doing this type of work, or?
They certainly are. Each of the major chemical companies, agricultural chemical companies, has got a program something like ours.
Agriculture innovation is usually dominated by massive corporations, companies like Bayer, Syngenta, Corteva, because they have the resources to fund research, navigate regulations, and scale products globally. But startups have a different advantage: speed and focus. Without layers of bureaucracy, they can develop ideas and bring them to market much faster. The challenge is securing the resources to compete at scale.
We started early and built up a large library of chemicals, and I think had a little bit of advantage in some respect in time. We certainly don't have we don't have as much money as Bayer or Syngenta or all the other people, but we do have intellectual property that we patented through the NRC and now the university. The molecules that are unique in having this property have been able to essentially keep the plant's stress response system on longer, and it works in practice.
And it's not uncommon for small startup companies to have innovative products or beat larger company to the mark because of their ability to respond more quickly, or maybe just out of luck. I worked for another startup company, and one of our scientists did the same thing. Everybody was looking at trying to produce fish oils and plants, and the large companies were doing this, but because he was limited in his resources, he was creative and he found a pathway and he beat other people to the market. So they had to collaborate with us if they wanted to get access to that technology.
Yeah, and scientific innovation comes in lots of different forms, and I think that's absolutely right. And so, you've obviously identified the market is very, very large. We have great producers in all over the world that are obviously incredibly passionate about the products. Consumers love it. This is also applicable to other plants and fruits as well. And I think our weather patterns are going to continue to disrupt this whole industry. And at the same time, we need to feed more people. We expect 10 billion people with more and more appetites. And so this is a really big problem with a big market. How do you secure funding for research and development? You mentioned obviously want more money, but how do you currently get it now?
Well, we have been at our stage of development. We've been working with family, friends, angel investors, and we've raised enough to keep the process, keep the research going. We've also used the money that we've been able to raise from our own bank accounts and our own efforts and our investors. We've been able to leverage that with government funding and grants and producer support from producer groups. The Ontario grape growers have funded our research in Ontario for over 6 years, and we've actually established a partnership with them. So they actually contribute to it. And we're seeking more investment, a larger amount. The larger the funding amounts that we're able to gain, the quicker we'll be able to access some of these markets and be able to get our product out to a larger group of producers who are in desperate need of it. When our stories came out in CBC and Maclean's, we were inundated with calls from producers, cherry growers in BC, blueberry growers in Prince Edward Island, grape growers in Nova Scotia, people that we hadn't worked with before. And we had all of these calls. Even the BC government called us and asked us how they might help us get our product into the customers, because they said it's been widely spread in the industry.
Yeah, and I guess that takes me to the market and how do you go to market? And I guess the first question is just how do you produce this? And the second part of that is obviously we're talking about a segment of the market right now that are obviously dealing with some issues with climate. And so that means that it's hitting their pockets. And so I guess what does the cost end up being for these growers? And obviously there's lots of incentives to growers from the governments because they want to have more food grown locally. So where do you grow it? And guess what's the cost structure for it?
Well, basically, our product, as Sue has suggested, is derived from that natural hormone itself, which is now made around the world through fermentation process, and that's available. And the natural ABA is sold in the marketplace now for specific functions. And unfortunately, the natural ABA doesn't help in the issues we've been talking about. But basically, we have a manufacturer then who takes our patented process. We found them. It was a former employer of chemist who works in the lab with Sue, and it's his former company, and they've developed the process for scaling up the manufacture. And the manufacturing process is very dependent on the volume. So as we get larger volumes and get more demand for the product, the price will go down. Sue and her team are also working very diligently on continuing to reduce our cost structure. Right now, we think the costs are around $1,000 per acre. Our goal is to get it to $500 an acre through a variety of different strategies we have for cost reduction, which includes scale up of the manufacturing.
And also delivery systems. The more effectively we can get the chemical into the plant and to where it's got to go and last, then the less we'll have to use. So we're trying on a variety of different approaches to reduce the amount that's required to be sprayed, to make it efficient, and to make the chemical process efficient. But as Jerome said, the natural hormone is now produced on very, very large ton scale. So it's available and readily. So it's, I think, coming along the way to being an extremely practical process.
And the process for the vineyards and the orchards is the same as any other spraying application?
Absolutely. You get a 4-liter jug and then just add water and then just spray it on the leaves after the fruit has been harvested. So the crop has already been harvested. The plant is going to go into its winter cycle sooner or later. And so the idea is when you've got the fruit removed, you spray the vines in the normal way that you'd spray other chemicals on your grape vines, and the rest nature does.
And at what point do you get to the market where you feel comfortable to just kind of scale this beyond and start selling this into all the different orchards? Like, is there a certain mixture between research and studying versus real world application? And how much do you need of both to really kind of say, listen, folks, this works. This is an easy application. Yeah. And how do we kind of scale it from here? Even if a technology is backed by decades of research, it doesn't mean farmers can start using it right away. Every new agricultural product has to go through extensive regulatory approval. That means proving it's safe for the environment, effective for its intended use, and doesn't introduce unintended consequences. This process can take years, and is one of the biggest hurdles to getting this technology to market.
Well, a step that's a very important one, and that is to get regulatory approval. So right now in Canada, we've hired a consultant to work with us to apply to the Canadian Food Inspection Agency so that we could sell this formulation of our chemical to grape growers. And that then will be checked by the government to make sure it's totally safe. And this is as a fertilizer supplement, since the chemical is providing positive benefits and increasing the plant's ability to withstand cold stress in the winter and in the spring. This is a beneficial product. And so this is the fertilizer supplement route is the way that we're going for the registration of this molecule. So once it's registered, then it can be sold and tried by people in working on or grow wine grapes and the other fruits, hopefully, and we'll all learn together.
So we, from working with our consultant and CFIA, we've been told that the process takes 250 working days, and we're about a month or more into that process, gathering the data, developing the label for the product, and making the claims we want to make with the product. So that process is underway, and it should be ready to sell in Canada within 250 working days.
250 working days after submission. We haven't submitted yet, but we're crossing the T's.
Is there any skepticism around the product, obviously, considering that it is a natural process? Spraying the plants with this, is there any, modification that people are worried about that need to be concerned about or tested?
Not so far. We're having people who have expertise in the field do the testing at Penn State and Cornell. And once we get registration in Canada, then Canadian researchers will be able to use it in the field as well. So it's the experts who are being funded through their organizations who are delivering the story on the results of our testing.
And we're remind you that the grape growers of Ontario are actually funding the research. Mm-hmm. And so they're fully aware of this. They get regular report from the researcher at Brock University. And they have been very enthusiastic and excited about getting this product going. And the more results they hear year after year, the more enthusiastic they are about it. And that's why they signed the agreement to help market the product.
So obviously the two of you being in your position to be able to develop this and take this to research to get this certified to then now get this onto the farms, as your expertise is there. Once this gets approved, what's the business plan? Is it to hire a big team? Is it to find and partner with some of these chemical? Like, how do you anticipate potentially that kind of next step? Because like you said, the demand is obviously there. I think that people are naturally looking for solutions. The government is not only providing insurance for a lot of these growers and help are probably also like, this is great for us to provide it to our growers too. So like, what's that possible next step look like once this gets all approved?
Well, basically, we are keeping all of our options open. But given where we're at right now, our goal is to grow the business and keep it as Canadian as possible. Keep our research center and the corporate head in Saskatoon, Saskatchewan. But there are a variety of different ways that we can work. We have a subcontractor, like I said, in India, who is doing the manufacturing. We have identified at least 2 or 3 different distributors who want to distribute the product once the regulatory approval is achieved. And there are other ways we can get it quicker to the market through licensing agreement with companies from other parts of the world. We've been talking to an Egyptian company who is interested in this product. We're working with a Chinese company, and these are places where they have the same issues. So rather than us putting our boots on the ground there, we might work in collaboration with companies who have the capacity to grow and manufacture and distribute the markets in other places for us. But our goal is to grow the business here in Canada, North America, and as much as we can. A lot of that will depend on the investment that we're able to obtain. And I think in Canada, we're getting very close to being able to get this product out there. And given the partnerships that we've put together, we think when the product is registered, we'll be able to move quickly on getting it into the hands of the producers.
Obviously, the agriculture industry faces immense challenges in the coming decades, and what you're able to put into the market right now is obviously incredibly exciting. What do you hope for the future? Is it millions of acres? Like, what's your big kind of larger vision? If this technology reaches commercial scale, it could fundamentally change how we think about farming in a volatile climate. Right now, farmers have limited tools to fight extreme weather. They can install wind machines, burn fuel to warm up orchards, but these are expensive solutions that don't always work. A simple spray that increases a plant's natural resilience would be a game changer, opening up new growing regions and reducing risk.
Well, we've really just talked to you about one product and about one specific type of application. So that's the beauty of our product is this hormone that the product is based on or derived from has a lot of functions related to stress in a lot of different crops. We're doing experimentation right now with canola, with lentils, with soybean. Those are areas where we're targeting our second product, which does the reverse of our first product. It blocks the pathway of the hormone.
Yes, and that's particularly useful for, say, getting seeds to germinate in colder soil. So soybeans, for example, grow in southern Ontario well, but further north and west you get, the colder it gets, you can't grow them because there's not a long enough season. So the idea of blocking the action of this hormone, again, has a real practical application, and that's called an antagonist. So we have a really good antagonist and we have a really good agonist. It's the agonist that works for that we use for the grapes and other stress-related projects.
So you see, basically, the way we like to talk about our product is that it's a platform technology. It's a toolkit for producers of a wide variety of commercial crops to be able to use to help them mitigate climate extremes, which is becoming an increasing issue for producers of all kinds of commercial crops all over the world. And our product isn't just limited. Sue had alluded to this earlier. It's not just limited to cold tolerance. It also can work and have a positive effect on drought and heat stress and a variety of other different kinds of stresses, even some pathogens. So we see that this is getting the platform in as many different crops, solving as many problems related to climate and other environmental stresses as possible. Because producers, as you said earlier, the demand for food is growing. It's not going to get smaller, and the population is getting larger, and the challenges for producers to make product that survive these challenges is increasing. So our goal is to provide producers with that toolkit.
And for those other applications too, is the idea that for areas that used to grow X type of product, but can no longer grow it because of whatever climate factor, there now opens up opportunities to grow a different type of plant that potentially wasn't able to grow before?
Yeah, absolutely.
Yeah, that would be the case in soybean, for example.
Yeah. And we actually did a study with growing rice in Alberta. So there's potential to open up opportunities to grow crops in Canada that are in demand in other parts of the world, but they've run out of capacity there. So that was just an early stage pilot experiment, but there is potential to do that. Absolutely.
Yeah, and stresses are not going to go away on growers and our environment with all of this. So this is obviously incredibly fascinating about the different opportunities and solving really a sector that we need, and a sector that anybody that knows any farmers, it is a very, very, very tough business. And so anything to give them an opportunity to have some risk taken off the table, I'm sure is open arms.
Yeah.
What keeps either of you up at night when it comes to all of this? Because this is like big game-changing technology, and there's a lot of people that obviously, their livelihoods right now are at risk with this temperature changes. What kind of keeps you up at night?
Well, different things keep us up. I'm focused on the business side of the operation, and Sue is on the scientific side. What keeps me up is fundraising, is making sure that we can find adequate resources to enable us to do what we need to do to get the product out there. And at the point that we're in development, that is easier said than done. The markets went through a lot of stress over the last couple of years, and we're hoping that that's going to change. We're getting more and more interest from investors of all types. So we're hoping that over the next few months, we'll succeed in raising the funds that we need to get this product out there, develop the marketing strategy, continue with the cost reduction efforts that we've been focused on right from day one, basically. Sue, what keeps you up at night?
Actually, it's the money part too, because the science is rolling. We know what we have to do. It's a matter of being able to find the resources to be able to do a really good job, to be able to do the science correctly so that everybody has confidence in the results. And they'll see the results in the field, but we need to do all the background work to make sure that we know we know where the levels are very low, but all that takes resources and effort to convince ourselves and everybody else that it's really as good as we think it is. But I think we're definitely got traction, and we have a product now. The first product, the ABA Boost, Jerome's name, really is, I think, a very fine product too, and I'm very pleased with the way it's going.
Funding is always a difficult thing, but there's also, what kind of funding are you looking for right now at this moment? Developing a technology like this takes years, but scaling it to a level where it makes an impact takes significant investment. Right now, they're at a turning point. They've proven the science, secured patents, and begun working with industry partners. But to get this into farmers' hands, they need capital to fund regulatory approvals, manufacturing, and distribution. The question is, will investors recognize the opportunity in time?
Our goal is to raise $600,000 by the end of Q1 in 2025. And then for the end of that calendar year and Q3, Q4, we're looking to raise another $1.5 million.
And there also seems like there's lots of governments that are there to support these type of things too. And I know like in BC, the government has a lot of grants and funding right now for these type of initiative. And so hopefully you guys can solve that and you can sleep a little bit better and think about all the acres that you can grow in.
We certainly, with the help of the BC government, we've talked to Agriculture Canada people in British Columbia. They're interested. They've got the provincial people behind them. So yes, they're very helpful. We'll work together.
Sue, Jerome, that was a lot of fun talking about agriculture. We hear a lot of negative stuff right now from grape growers losing most of their production. You hear this in France. You hear this in kind of all parts of the world, and Georgia not having any peaches. And it has a lot to do with this stress. The weather is obviously wrecking havoc to our agriculture. You've come up with this process to basically put a natural antifreeze on vineyards and orchards. Can you talk to me a little bit about what that means in natural antifreeze and what this kind of market looks like?
Well, I can talk about what the chemical is. So, how does it work? The chemicals in plants, natural chemical in plant, will keep a plant cold hardy for its natural cycle. But if with climate change, when the weather gets colder later, when the natural signal has stopped doing its job, if we give it a longer pulse of the same process, chemical, then we will essentially give a longer lasting effect and have the grapevine be able to withstand longer stress.
That's it for today's episode of Someone Like You. We've just scratched the surface on how climate change is disrupting agriculture and how innovative solutions like the one from Abezine's Bioscience can give farmers the tools they need to adapt. Sue and Jerome's work shows that nature already has the answers. We just need to make them work at scale. And as we've heard, the potential impact is enormous. Fewer crop failures, more resilient harvests, and a future where unpredictable weather doesn't mean disasters for farmers. If you want to learn more about Abezine Bioscience and their groundbreaking technology, check out the links in the show notes. And if you enjoyed this episode, don't forget to subscribe and leave a review. Thanks for listening, and as always, keep breaking the rules strategically.